Okay, we know how to write equations of circles now, so we're just going to keep practicing it. We're also going to graph them, so we'll talk about how do you graph a nice circle, and then we're going to get into domain and range. So write an equation of the circle, sketch its graph. What are the domain and range of the relation? Hey, did you notice it's calling it a relation right now? They're not calling it a function. Is a circle a function? If you guys remember the vertical line test, it hits a circle twice at most spots as you pass a vertical line across a circle, so it's not a function. You have two possible outputs for a single input, and that is not a function. So we're calling it a relation. All right, part A. The circle centered at the origin with radius square root of 3. So the center of our circle, let's just identify that, is 0, 0. The radius is equal to square root of 3. So that center of your circle, that's our h, that's our k. We're going to just go right into our equation, x minus h squared plus y minus k squared. And I just plugged in the zeros for those h and k, equals your radius, square root of 3 squared. And then we'll simplify. X minus 0 is x, carry down your squared, plus y minus 0 is y, carry down your squared. Square root of 3 squared is square root of 3 times square root of 3, which is the square root of 9, which is 3. So there's the equation of the circle. To graph this, we're going to start always by plotting the center of your circle first. So the center of our circle is at 0, 0. There we go. And the radius is the square root of 3. So we use the center of the circle and the radius to graph these. What we're going to do is, I don't have a square root of 3 on my graph, so we'll just grab a calculator and figure out that the square root of 3 is about equal to a 1.7. So we're going to do a little bit of estimating in our graph. But in our graph, you plot your radius, and then you're going to go 1.7 units to the right, to the left, up, and down. And we're just going to plot 4 points on the circle, but horizontally and vertically, because we can count 1.7 units to the right, 1.7 units to the left, 1.7 units up, and 1.7 units down. And then our circle is just going to go through those outer points with that center in the middle. And there we have our circle. All right, so domain and range. The domain, we know, is our x values. If we think about visually, the domain is how far to the left does your graph go and how far to the right does your graph go. So we're going to identify our domain. And let's use interval notation. To the left, the furthest we get is it's a negative 1.7, but remember that was an estimated value of the square root of 3. So it's a negative square root of 3. That's the smallest x value all the way to the left that we're going to get. And it goes all the way over here to the right to a positive square root of 3. So our domain interval is negative root 3 to positive root 3. And those are part of the domain, so we will include them with brackets. The range, what is the lowest value of our range? We went down 1.7 units, so it went down to a negative root 3, and we went up that 1.7 units, which is a positive root 3. So the range in this example, because the center of our circle is at the origin, actually is the same. It goes from a negative root 3 to a positive root 3. All right, so we're going to try just one more. There we go. All right, so let's do another one. We're going to write an equation for a circle that's centered at 3, 5 and has a radius of 5 halves. So 3, 5, that gives us our h and our k value, and the radius is the 5 halves. So we're going to go ahead and follow standard form of an equation. X minus h minus a negative 3 turns into plus 3. squared plus y minus our k, which is 5 squared, equals 5 halves squared. So I'm just going to think about squaring that up there. That is a 5 halves times another 5 halves. So we get 25 fourths. So there's our equation of the circle. Now when we graph the circle, we really just need the center and the radius to get the graph. We know the center is at negative 3, 5, so we'll start by plotting the point negative 3, 5. And our radius is, I already forgot, 5 halves. So the radius is 5 halves. And then that is a 2.5. That's going to be a little bit easier for us to graph if we see it as a 2.5. So from the center of your circle, you're going to go 2.5 units in 4 directions, left, right, up, and down. So we're going to go to the left, 1, 2.5 units, plot your point, go back to the center. Go to the right, 1, 2.5 units, go back to the center. Go down 2.5 units, back to the center, and go up 2.5 units. That's going to take you off your graph just a little bit, but that's okay. And now we draw the circle in, going around those 4 points as best we can. Make it as nice of a circle as you can. Okay, so we have our circle drawn nice and neat. And last we just have to identify the domain and range. There we go. All right, domain. If we look at our graph, how far to the left, how far to the right does that domain go? Does our graph go? So if you go to the center, we're at a negative 3. We're going to go to the left 1, 2.5 units. So that actually puts us at a negative 5.5. That is the smallest value of our domain. The largest value, if we continue out here, we were at a negative 3 and we moved to the right 1, 2.5 units. So that is a negative 0.5. Those are included in the domain, so we use brackets. Our range, the smallest value of our range is going to be down here. We can see it's up 1, 2, and we were on the halfway point. So it goes from 2.5 all the way up to, let's see, here we're at 5, 6, 7.5. So up to 7.5. And there's our range.